Okay, we're going to finish with a big fat question about without replacement sampling. So we're choosing from without replacement from this choir. Add up these numbers, 12 plus 15 plus 5 plus 8 is 40 singers. So I'll need that total of 40. And I'm choosing 3 members of the group at random, and I want them to firstly all be basses. Well, this is good. There's only one order that can happen in it. It's got to be bass, then another bass, then another bass. The chance that the first one's a bass is 5 over 40, so I now need to multiply by 4, but now there are only 39 left. And then times the number of basses after that will be 3 over 38. And my trusty calculator tells me that's 1 over 988. Okay, I have some lovely big numbers in my fractions. Okay, part B, at least one soprano is nearly as easy as that, because remember the probability of at least one is 1 minus the probability of no sopranos. Okay, so therefore I want the probability that the first one's not a soprano, this next one isn't, and the next one isn't. Okay, and then I want to take that away from 1. So I'm doing 1 minus this. Okay, so I'm doing 1 minus. What's the probability I don't get a soprano? Well, there are 12 sopranos. That means there are 28 of the 40 left to not be sopranos. So I need to do 28 times 27 over 39 times 26 over 38. There's only one order that I can get all 3 not being sopranos, so I can change my previous answer. So here we go, I've put that into the calculator, and the calculator tells me it's 127 over 190. Okay, the next one, this could happen in different orders. It could be soprano, then tenor, then bass, and that will be, for the soprano, it'll be 28/40ths. And then I'm going to have 39 choir members left, okay, but all along there have been 8 tenors, so it's 8 over 39, and 5 basses, but now that's out of 38, so that's one way it could happen. But there are other ways. For example, I could still have a soprano first, but then a bass, and then a tenor. Okay, well that's going to be 28 out of 40, and then for the bass it's going to be 5 chances out of 39, and then for the tenor it's going to be 8 chances of 38, and I can see I'm going to get the same answer to these two even though the probabilities within them are different. So from this point onwards I'm going to accept the fact that there are going to be several different orders this can happen in, so I'm just going to need to multiply this calculation by the right number. So what orders are there? Try and be systematic. So I've had 2 beginning with sopranos, so therefore I'm going to expect there to be 2 beginning with tenors. Yes, it could be tenor, soprano, bass, or tenor, bass, soprano, and similarly there are going to be 2 beginning with bass. It could go soprano, tenor, or it could go tenor, soprano. So if you're systematic you should get the right number of options, which is 6, and then all we have to do is that calculation. There it is, and the answer is 28 over 247. So we're storming through this question. Now we've got to do 2 tenors and a bass. So one way that could happen is tenor, tenor, bass. Okay, how many tenors were there? 6. So 6 over 40 times, now there are only 5 tenors left for the second one, 5 over 39 times, and there are 5 basses, and there are 38 people left. So that's one possible order. But it could also be tenor, bass, tenor, or bass, bass, tenor. Those are the only possible orders. If you work out the probabilities using fractions, they turn out to be equivalent to this one. So I just need to multiply this one up by 3 and enter that on my calculator. There we go, and the answer is 15 over 1976. And now for the mean part of the question, this is a conditional probability. We want the probability of 2 altos given that it contains at least 1 alto. Okay, so I've given my event slightly unusual names, but we need to remember that this is the conditional probability formula. So on the top I want the probability of both of these things happening, so 2 altos happening and there being greater than 1 alto, and on the bottom, remember, it's just the formula for what's on the bottom. So on the bottom I want the probability there's at least 1 alto. Okay, well, the top probability looks confusing, but in fact, if you think about the number of altos, if there are at least 2 altos, and then if there are 2 altos, then there must necessarily be at least 1. There's no way that there can be 2 altos and then not be at least 1. So the fact that there are 2 altos and at least 1 alto altogether just means there are 2 altos plus another. Okay, one that isn't an alto. So in other words, it's going to be alto, alto, not alto, or alto, not alto, alto, or alto, sorry, not alto, alto, alto. These are the three ways that I can have two altos, and in all of them, okay, I've obviously got at least one alto. There's no way of not having that. So my top probability, that looks a little bit confusing, is just the probability of these, which is going to be 3 times. There were 15 altos, so 15 40ths for the first one. Okay, for the next one, 14 39ths, and then for the one not to be an alto, there were originally 25 non-altos, they're all still there, so 25 over 38ths. Okay, if I worked out the probabilities for the other two, then they'd come out slightly differently in appearance, but they'd be the same as this one here. So I can multiply this one by 3 to get the probability I need for the top. So there's the calculation we've set up, and the answer is 525 over 1976. Now that leaves me with the bottom calculation to do, the probability of at least one alto. So the probability of at least one alto is 1 minus the probability that none of them are altos. We've used that before. So the probability of alto, 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 this is going to be 1 minus. The probability the first one's not an alto, sorry, I should say not alto, not alto, not alto. First not alto is 25 40ths. Next one, there are 24 non-altos left out of 39, and then there are 23 out of 38. So do that calculation. There it is. And we've got 379, okay, over 494. So the probability I want, this conditional probability, I've set up the formula for it. I now know I need 525 over 1976 divided by 379 over 494, which my long-suffering calculator will do. Here we go, and the answer is 525 over 1516, which is about a third. Okay, now for this last part, I've got to redo C and D, but now the selection is with replacement. So I'm not going to need to change a lot. Here was my answer to C. I want one of each. So I had a multiplication by 6. I'm still going to have a multiplication by 6. It's just that my 28 sopranos are going to be followed up by one of the 8 basses, okay? But now it's going to be out of 40. I've put that soprano back, so there are no longer just 39 choir members left. So it's going to be, in my solution, 6 times 28 over 40 times 8 over 40 times 5 over 40 for my answer to C. And for my answer to D, which was up here, all right, once again, what's going to change here is that the probability of a tenor on both occasions is going to be 6 over 40. I don't need to update it to 5 over 39, and the probability of a bass is 5 over 40. So for the second one, I've still got the times 3. So for the updated part D, I need to do my 3 times my 6 over 40. The second tenor is also 6 over 40, and the bass is 5 over 40. So those are my updated answers to C and D, which I'm going to give my calculator a rest from calculating. This is a calculation that's the important bit. Okay, 8.5 minutes, not too bad, because that was really quite a meaty question. Well done for surviving.